Real quick, can you guys run me through the four you already know? I only got Grace in here.
And
Good. All right, here's your fifth and final one. This is it. This is the fifth one, and this is the only five we're rolling with, because that's the only five there are. HL. HL stands for, the H stands for hypotenuse, and the L stands for leg. Hypotenuse, leg. The only time you can have a hypotenuse is if you have a right triangle. So this method is only reserved for right triangles. That's it. Excuse me. Only reserved for right triangles. If you don't have a right triangle, HL is not even an option. It's only for right triangles. Let me go through quickly because I don't think you guys are familiar with hypotenuse and leg. So let me go over real quick this method here. What do you guys know about a hypotenuse when you hear that word? Anything or no? And it's okay because you guys just don't have the background yet. Hypotenuse is the longest side in a right triangle. It's always located across from the right angle. Okay? Hypotenuse always across from the right angle. So these would need to be congruent. And I don't even know, what is it? Hypotenuses? Hypoteni? Anybody know? Have a guess? The hypotenuses or the hypoteni are congruent? No? I don't know. Hypoteni? I've been teaching this 18 years now. I have no idea. It's like rhinoceros. What's the plural of rhinoceros, right? Rhinos. Good. You took my joke away, Grace. Yes, rhinos. Good. That's the hypotenuse. All right. It's across from the right angle. Across from the right angle. But the other two are legs. So either of the other two could be congruent. So watch. That's HL. But the angle's not in, but it doesn't matter. It's a right triangle where the hypoteni are congruent and the legs are congruent. That's HL. Or I could have done this. That's HL. Okay, that's still HL. Grace, question?
Could you do both? And then...
What do you mean both? Both legs?
Yeah.
What would be? You could have side angle side then.
Yeah.
Yeah, that wouldn't be HL. But yep, and this is what I was going to get into too. Just because you guys see a right triangle does not equal HL. Watch. Got a right triangle? Right? Two right triangles. That's not HL, but it is still what? Angle side angle. So I just don't want you guys to get in the mindset, oh, I see a right triangle, that means HL. No, you have to have the hypoteni congruent and the legs congruent to do HL. Everyone all right? Okay, this is why we save it for last too, because it kind of doesn't fit into the side angle side type deal. All right, but it's still a method to prove triangles congruent. And that's what we're going to focus on today, is using this method differently. All right, ready? All right, let's start our first proof. Sorry. I'm going to walk you through each of this. I'm going to walk you through the first one because there's some little details you need in an HL proof. So ABC is a right angle. DCB is a right angle. Got it. Everyone ready? AC is congruent to DB. What did we just mark congruent in those two triangles? The what? Those are the hypoteni, right? Everyone agrees they're across from the right angle. So you just marked the hypoteni congruent. And it's already written in there for you. Look, you're welcome. Okay, what else could you guys still mark? These are still triangle proofs. We just did a couple days on it. Kevin?
BC equals BC.
BC equals BC. And that's a what of the right triangles?
Leg.
That's a leg. So you got HL. So I have BC congruent to BC, reflexive. And now I wish we could go right to step 3 and just say they're congruent by HL, but we can't. Okay, we can't. Do I have the hypoteni? I do. Do I have the leg? I do. But I need more though. Okay. Hi, Tim. What's up?
You need the right angle congruent.
All right, we'll talk about that in a second. We'll talk about that. HL only works for what type of triangles? Right triangles. So if you're going to use HL in a proof, you need to tell me you have right triangles. Okay? You need to tell me that you have right triangles before using HL. Do I have right triangles? How do you know you have right triangles? How do you know these are right triangles? Because they have? Okay, so what I need to say first, though, before I go to HL is triangle ABC and triangle DCB are right triangles. I don't have it on my notes here, but does everyone see the note right below HL? You must establish that you have right triangles to use HL. What do you think a good reason would be? Why they're right triangles? You guys just answered it a couple seconds ago. How do I know they're right triangles? Right triangles have right angles. Whoa, wait. Right triangles have, did you tell me you had right angles? Did you tell me you had right angles, or are they just marked in the diagram? Did you tell me in the proof you had right angles? Where? Good. Okay, it was given to us, right? Right there. It was given. So good. Right triangles have right angles. Now, Tim mentioned a couple minutes ago, you got to say the right angles are congruent. You can, it's not wrong, but in HL, what's the H stand for? Hypotenuse, what's the L? There's no mention of angles. So you don't need to say the right angles are congruent in an HL proof. Is it wrong if you do? No, you can, just to be on the safe side, but all I need is right triangles, the hypotenuse, and the leg. I do not need to say the right angles are congruent. Grace?
What would your reasoning be if you didn't have a reflexive? So if you were like,
I probably couldn't prove the triangle's congruent
okay,
because I would only have the sides and that's it.
okay.
Right? That's all. I have angle, side, nothing. So that wouldn't be possible. And then finally, now that I have right triangles, I could say triangle ABC congruent to triangle DCB by my new method, hypotenuse, leg, HL. But it's got to be a right triangle. And you got to make sure you state it's a right triangle. Anything here, your first one, doesn't make you great. I know we're still feel uncomfortable. That's why I got some more examples coming up. Wow, look at this one. This looks like a ton going on. Time out. Look at the proof statement. 1 congruent to 2. Those angles aren't going to be congruent unless the triangles are. Does anybody know what type of proof this is going to be at the very, very end? What's going to make 1 congruent to 2 after we prove the triangle's congruent? A little old CP, CTC. Good, but it doesn't happen unless the triangles are congruent. So do we see the triangles that contain 1 and 2? Do we see them? Let's get them congruent. All right, let's see if we can get them congruent so we can say CP, CTC. Ooh, perpendicular lines, nice. So hopefully we're drawing right angle symbols here and CF and BD here. Oh, this is, wow. I really gave it to you on this one. BF is congruent to DE. Woohoo! And AB is congruent to CD. Got it. Okay, let's make a plan before we write down statement 2. I do have right triangles. That does not necessarily mean HL. AB and DC would be one of those right triangles. What are AB and DC in those right triangles? They're across, so they are that's the, so I have the hypoteni congruent right here. What else could you get congruent here? What else we're going to have to write in? Any other sides you could see or angles congruent? Go ahead, Grace.
You could say AE is congruent to AE and
AE,
yeah, and CF is congruent to CF.
but it doesn't make them congruent to each other,
No,
which I need congruent.
you need them congruent to each other.
Correct. Right? You're just saying AE, this side is equal to the same side.
Yeah.
This side's equal to its side, but I need AE and CF to be equal to each other.
Okay.
Right? They can't, I don't want them equal to themselves. I want them equal to each other. Reka, what do you have?
Just do subtraction.
Where?
With BF. Well, first you have to do EF is equal to EF.
Everyone, EF equal to itself, and then do a little subtraction to get sides BE and FD congruent. Everyone good? And then does everyone see the HL? Because BE and FD would be the legs. Yes, no? I don't want to keep moving on unless we see it here. Because this is going to, it gets real tough now, because now you got 5 reasons. Okay, here we go. So let me do the subtraction here. EF congruent to EF, because I need that as my second equal quantity to subtract. Reflexive. Now I'll subtract. What do I got? BF minus EF equals ED minus EF. Subtraction. What always comes after subtraction? Okay, now we can say BE congruent to FD. Substitution. Do you guys see HL? Do you see HL? Why is it, let me ask you this question. Why is it not side angle side? Why is it not side angle side? This is how I know you're on top of your game. Maisha, hold on, Maisha, go ahead.
The angle's not in between.
Correct. The right angle is not in between my congruent sides, but it is still a right triangle where I have the hypotenuse and the legs congruent. All right. What else do I still need to add in my proof, though? Because I'm not ready for HL. Matt. Good. I can't say the right triangles until I have right angles. So that's my step 5. Or I could have done it in step 4 or step 2 as well. Angle. Am I missing? No, I'm not. That's AEB. Angle AEB and angle CFD are right angles. Perpendicular lines form right angles. Now, if you're just in the habit, just say, oh, all right, next step, I got to say they're equal, that's fine. But in an HL proof, you don't need to tell me the right angles are congruent, but you can if you want. I'm never going to mark you wrong for it. Still not ready for HL. What do I have to tell you about the triangles? They're right triangles. HL is only in right triangles. So now triangle ABE and triangle ABE. And again, these don't have to match up until I make them congruent, but ABE, DCF, might as well right now, are right triangles. Right triangles have right angles. Okay, now I think we're good. Now you can tell me they're congruent. Who would have thought 8 steps, huh? In such a fast amount of time. HL. And then good old 1 congruent to 2. Look at you, 8 proofs. Look at you. Big boy, big girls, huh? Questions from you guys? All right, you ready to go to an honors level proof that I don't do with my other geometry class? Okay, quick question. Hold on, let's not get going here. What don't you like about this proof right away? As you look over everything, what's really making people uncomfortable? And I don't blame you.
Exterior.
Okay. I don't know if I'll need them, but the exterior angles are the diagram's making you uncomfortable, Kevin.
You have to prove a bisector?
Yeah, the proof statement. What about that? Come on. I've only asked you guys to prove things congruent. Now I'm all of a sudden I'm asking you to prove that AB bisects DAC. What's your deal?
Well, don't you just have to prove that the angles are congruent?
Well, here's my question now. If AB is going to bisect DAC, ready? If AB is going to bisect DAC, what two angles should be congruent before I do that? Matt. Angle DAB should be equal to or congruent to angle BAC before I say it bisects. Correct. That's your group's job right now. Right there. Do it. Do it. Prove those two angles. Get those two angles, and I'll help you with the final step. Let's go. Let's go. Talk it over. How do I get those two angles congruent? You got it. You got it. I'll give you some time to think, and then I'll write mine up on the board. Get those two angles congruent so we can confidently say AB is a bisector. Strong group. Strong group. All business, this group, huh? Don't want to share your brilliance with each other? All right, time for me to put my version up here. Doesn't have to be in that order, but those are all the piece parts that have to be in there. How's it look for you guys, right? CPCTC, getting those angles equal, getting the triangles. Now, if you had right angles congruent, fine, leave it. You're good. Any questions on my proof that you want to ask compared to yours? So we prove the angles congruent. Okay, the angles are definitely congruent. Now that's got to mean that AB bisects DAC. Everyone agrees? If those two angles are equal, yes, AB bisects angle, and I got to look for it for the third time, DAC. But here's the thing, though. I don't want definition of a bisector. Here's the example I give every year. Chloe, you're sitting in a chair. If I ask you guys, how do I know Chloe's sitting in a chair? Oh, definition of a chair. Does that tell me anything that you know anything about a chair? No. So tell me something about a bisector that you know that AB bisects DAC instead of just saying it's a bisector. How do you know? How do you know? Tim, give me a little something.
Bisector creates two equal angles.
That's fine. And what are those two equal angles it created?
DAB and DAC.
So I'd be fine with you guys writing because DAB is congruent to BAC. I'd be perfectly fine with that. I just didn't want definition of a bisector. Hi, I'm sitting in a chair. How do you know that? That's the definition of a chair. Doesn't tell me anything about a chair, right? Tell me something about it. Those AB bisects DAC because these two angles are equal. You guys good? And that ends today, right? Okay, so let's talk about Unit 3, Parallel and Perpendicular Lines Test. How do you think you did? Huh?